Hello, everybody. Um, Today, we are going to be talking to you about building PayPal's global payment experience. So what is global payment experience? You're shopping online, and you have checked out a few items. You go to your cart, and then you see an option to pay with PayPal. You click on the button. The experience you see there is our global payment experience. And this is one of the most trafficked and bread and butter, I should say, of PayPal. The move to Node for this experience started in 2013 around November. The prototyping started around that time. And we deployed the very first version of Node around 2014, January to February. It's been performing well, but we started noticing some issues with respect to scaling. When I say scaling, with respect to scaling the team, as well as scaling the code base itself, like more and more features were getting added into it. And so the way we had structured it initially didn't seem like it was lending itself well to be scaled. So that's when the team decided to get together and deciding about rewriting it in a much better way that's more modular and more easily maintainable. So today, we are going to be talking to you about the story of how checkout got rewritten, the challenges that we faced in the first write, and the lessons we learned hence, and how we moved forward. I'm Purnima Venkatakrishnan. I'm from the team that open sourced Kraken. And we are also the team that helps most of our products move on board onto Node, and also help with various we analyze various products, the requirements, and then come up with patterns or solutions that kind of reduces work for most of the teams.
I'm Daniel. I'm a lead engineer on the checkout team at PayPal. I've been working on checkout for about 2 or 3 years now, so I've been building and rebuilding checkout. So as Purnima has mentioned already, in 2013, we had our first attempt at building checkout in Node. And obviously, we met a number of challenges doing so. Actually, we had our legacy kind of checkout app built in Java using Spring Webflow. And we were kind of building in parallel as an experiment in Node and trying to release in parallel and compare the two applications in Java and Java and Node at the same time. So actually, to begin with, we were sharing a lot of code between these two apps. We didn't want to change our front end at all because that was kind of in active development. So initially, our attempt was to kind of emulate what Spring Webflow does in Node. So we kind of built our own. There was really nothing like this at the time. In Node, we built our own kind of stateful Spring-like engine on the back end so that we could reuse a lot of our existing front-end code. So that was one of the kind of initial challenges for us, getting that up and running. Another factor was we were moving across kind of a lot of Java engineers at once, about 15 to 20 engineers that are primarily Java-based into a Node kind of environment. Everything's async. Everything's loosely typed. There's no compilation, no nothing. And kind of that took quite a bit of onboarding to get used to that. One of the big factors was moving to this kind of async environment. Obviously, everyone is kind of used to synchronous style code. One of the things we adopted very early on was a kind of very promise-heavy application. So we wanted some of our more traditional kind of error handling and our more synchronous code style without lots of nested callbacks or callback soup or anything like that. So promises were very, very useful in getting our team kind of quickly onboarded onto Node. Dust.js, again, as I mentioned, we were keeping our initial kind of Java Dust front end. So we just kind of ported all of that across onto Node rendering. So that worked for us initially, but obviously Dust.js doesn't give us an awful lot of flexibility in terms of building UIs. We can do kind of incremental renders, but we can't really get down to the kind of really granular level that more kind of advanced front-end frameworks will give us. Another of the challenges we have at PayPal is we have a lot of legacy infrastructure. And we have to write a lot of code to interface with that. All of our logging, our instrumentation, our monitoring is based on legacy Java and C++ stacks. And a lot of the Node modules we built to interface with these were kind of very young at the time, so getting those to work was difficult. We had a lot of memory leaks, a lot of CPU overloads, first of all, but in the last year we've kind of managed to scale those and work pretty closely with our infrastructure team to get those kind of up to scratch.
Yeah. So the memory leaks mainly because the checkout experience is, just like I mentioned, it's a highly trafficked app, and it was challenging our infrastructure in ways that it hadn't been challenged before, and it really helped as they ramped the first experience of checkout on Node to figure out different shortcomings in the existing modules and fix them along the way. As this proceeded, also the code base started growing, and since it was rapidly under development and their team always works with a high velocity and lots of high impacting features, the code base kind of became monolithic, and it became difficult to break down into modules simply because they were very closely tied functionality, tightly coupled. And so breaking down into modules kind of became a challenge. And hence, we generally, at PayPal, every around December, we kind of ramp down actual product releases, and what we call it a moratorium, where we kind of revisit all our backlogs and tech debts and see what can we fix and how we can improve our efficiencies better. And this is when the team decided to revisit and see if a rewrite actually makes sense. These are the few things, as you see, some of the things we wanted to revisit for the rewrite. And the team went away. The very first one is trying to adopt open source solutions for the flow, and get rid of the in-house written Spring Webflow kind of emulation on Node, and see if there are any other solutions that works better. And they experimented with Ember, React, and Angular, and kind of made prototypes to see which worked out better, which had a balance between the flexibility it gave versus the support it gave in terms of requirements of the product. And also, the other factor they wanted to factor in was the amount of community support that was provided by these open source solutions, because it becomes vital when you actually start using them in a highly trafficked app. And the team decided to go with Angular and decided to go on a very front-end heavy app and use Kraken more like a app API layer at that point. Scalability with distributed systems, simply because the team started growing and it was geographically getting distributed. There were teams from Bangalore in India, teams from Chennai that was getting onboarded. So all of them sharing one monolithic code base quickly became not a very great solution. So deciding to go more modular, more stateless, more simple modules that can be pulled in order to configure a product became more and more important. And thirdly, so most of our products have similar features, but they have different product offerings. So ability to have enough breakdown of the app such that these products can just pull in required modules, configure their app, and just get them running right away was very, very important. So
we really wanted to kind of take checkout and pull it down to the most kind of discrete units possible. I think at PayPal in the past, we've made the mistake of being too monolithic, and we've also made the mistake of being too granular, having components for the smallest UI fields and so on. So we wanted to try and find a nice middle ground. I think everyone at PayPal has experienced the fact that we do rewrite things a lot. Everyone at PayPal has probably had some experience building their own card, adding flow, for example. We wanted to get away from that and build something more reusable. So on the Node side, we came up with this kind of plugin architecture. So we really wanted a plugin that would host a set of REST APIs that we could just pull into our Kraken app, and it would set itself up, configure itself, and just serve traffic straight away. And that would essentially mean that we could have multiple Kraken apps that may need the same APIs, and they can just pull those in without having to do any complex integration. And actually, Kraken gives us a brilliant mechanism for doing that, which Purnima is going to demonstrate in a few slides. So on the front end, we kind of did the same thing. We went with Angular, so we're using kind of Angular directives very heavily as components. So we've broken down everything into Barrel modules, Angular directives. So we have now distinct flows and components like add card and authenticate that we can use across multiple apps very, very seamlessly. And we're already using those across 2 or 3 apps in production right now. Another challenge for us is internationalization. So a lot of apps, you'll have a logged in user from the very start. You know exactly what locale they need. Checkout is not so simple. We need to be able to show a locale on the login page that may not be the same locale the user will experience once they log in. We have an entire guest flow that doesn't even have an authenticated user. So we need to kind of very easily be able to switch out locales. And actually, Angular gave us a lot of support for that. The kind of two-way binding immediate updates on the page mean we can just switch out one JSON for another with all of our localization and all of our internationalization. And that works very, very seamlessly now.
So quickly, a review of what we talked about. So if you look at the Node.js side, you see the Kraken app, which is really a simple configuration layer on top of an Express app. And you have plugins registering themselves with the Kraken app itself. And these plugins are self-contained, and they bring their own routes. And on the browser, you can see the Angular app. And the components that you see that are all our Bava components that they kind of get pulled in by the front-end heavy Angular app. So at this point, the Angular app is actually communicating with the Kraken layer, which is really an API layer providing routes to provide like the JSON data that's required by the UI. So we kept repeating plugins. So what we mean by plugins is really sub-apps that are getting mounted on top of the parent Express app. When we started looking at this idea, there were a few requirements that we had to absolutely match before we started experimenting this. One is the team wanted the plugins to be really self-contained. Basically, this plugins will come in with its own host of routes. It will have its own input mapping, and it'll have instrumentation for every route that's being hit. It'll know about the services that it needs to talk to in order to get the data, and also like the output mapping as to what the data should look like when it's getting returned. Secondly, the plugin should be easy to write, simply because the teams are scaling. If they're going to add some feature, they should be able to pick a plugin, look at the semantics that are there, and be able to translate them into an equivalent plugin that has a different set of features that it brings in. So that was absolutely necessary. Thirdly, we wanted to make sure that the interface that it provides is really standard so that any other app or any other product out in PayPal who wanted similar features can easily just create a Kraken app and then pull in this plugin and register it mount it as a sub app on top of the parent, and hey, all the features come for free in that case. And fourthly, this is something that Daniel will talk about in detail when he's talking about move from Dust to Angular. We also wanted to make sure these plugins expose programmatic APIs to get the same data that you would get if you invoked in the form of a HTTP invocation to get some data. So a typical plugin would look like this. It's a highly oversimplified expression of what we're doing, but pretty much the essence of what we're doing is here. The module is basically going to return an app, and it'll internally set up. The module will be passed a plugin spec, and it'll set up the roles of the plugin based on the spec. And also, the spec would have routes, and it would have like what sort of instrumentation that needs to be done, and mapping of input and output data, et cetera. And the plugin exposes programmatic invocation part is basically a way to invoke the plugin get data, raw data from it without having to do a HTTP invocation. So Kraken, slightly going off track to explain if you're not familiar with Kraken, is just a middleware. It's just a configuration-aware layer on top of an Express app that lets you run your app, sets your app correctly based on your environment automatically by reading a bunch of configurations. So you would be able to, in your configuration, specify like a middleware just like that, and say what priority, what order, where you want the middleware to get inserted on your Express middleware stack. And you just provide a name and arguments to it. It'll basically look for a module in the Node modules folder and pull it out and then use it in the Express app. So this is exactly what you see in the second part of the code. So basically, all you'd have to do is write your config to set up your middleware, and then make Kraken read it, and that's all you need to do in order to add the plugin into your app. So that got it very easy for us to implement sub-apps for Kraken.
Moving on to the kind of front-end perspective, we wanted to move away from Dust.js to something a bit more flexible, and as we've already discussed, we went with Angular. So a few of the design decisions we made, I've kind of put up here. One thing we decided very early on to do was to keep a very distinct separation between our front end and our back end. Since Twitter decided that server-side rendering for the first response was the way to go, I think a lot of people have decided to go that way. We decided against that. And actually, in our experiments, rendering on the client side for the first response has actually had some very, very positive results in production. So we use a number of techniques to make that as fast as it can possibly be. So instead of rendering a page and having a load of HTTP requests go off, we'll render that initial page with all of the data it needs. We'll do early flushing so that the client can start downloading their data while we're preparing our data. And actually, it makes for a very, very fast and smooth experience. And as I said, in production, we've seen some very, very good results from that. The reason we wanted to do that was simply so our architecture could be a lot simpler. We don't want to have a server and a client that are both responsible for the same things. Even though it's just JavaScript, it does introduce complexity that we didn't really want at the time. So we ended up keeping our server as a REST API and having our client fully responsible for all of the flows, all of the states, and basically anything in the app that had to be stateful, which is moving well away from the kind of old Spring style approach. Given that we were using Angular, it gives us binding for free, which is great. Now our UIs are very, very easy to build. We can again have a separation between our front-end model layer and our front-end UI layer, in which we just update our models, and Angular pretty much takes care of keeping our UI in check for us. Another factor that we gained from this is a much faster build time. So the typical approach at PayPal traditionally has been to build all of the templates with all of the locales and pre-compile all of those. In Checkout, we have a lot of locales to support, and we have a lot of templates. And essentially, this was making kind of any front-end development slow in our team. So we really wanted to move away from that and keep our internationalization and our templates kind of separate at build time.
Yeah, so moving on. The next category we had to look at was the way error handling was done. There's a really good article from Join by TJ about it clearly maps out the sort of things that you have to investigate for error handling in Node. If you quickly skim through it, it actually says best way to recover from program errors is to crash immediately and recover. But don't just skim through it, just read through it in detail. It clearly states there that if there are shared states that are between requests, or if there are memory references that might stay around, if you have like a exception, programmer exception that's thrown, then you have to make sure that it immediately cleans up the process so that it doesn't leak. So with respect to checkout, when we revisited error handling, we noticed one thing. It's less than 0.2% of errors are actually programmatic exceptions that were happening. And most of them that happened were actually within the context of a request itself. That is basically, let's say a request comes in, and there's a service call that's happening. And let's say this user has a very weird user profile, and hence the service responded with a payload that is not something that's unusual, that the app didn't expect, and hence would throw a programmatic error. So early on, when we started looking at how we would want to break down error handling, there were a few requirements that came out of it. It is not, since checkout is so vital for PayPal, it is not acceptable to lose a transaction. So when a request comes in, let's say there is some exception that has happened, they wanted to preserve that somehow and at least try to attempt as much as possible to handhold the user to finish their transaction. In this case, they try to redirect it to the legacy site and see if that would get a conversion and completion of that transaction. Secondly, it is not acceptable to bring down an instance just for the sake of an exception. And thirdly, logging every single exception that happens and immediately acting upon it, which is kind of, if you look at the Joint article, that specifically calls it out as well. So moving on.
So the way we're achieving this in Checkout, we want to obviously be very error safe, as kind of Purnima has been saying. So I mentioned earlier that all of our checkout code is promise-based. We went with that decision very early on, largely due to its error handling capabilities. So we are pretty much guaranteed to know that if any exception happens in our checkout code, we're going to be able to catch it by virtue of the fact that we are using promises pretty much everywhere. And after we've done that, we can gracefully return the user to a legacy flow or to some recovery page or something like that. And the reason we know that's safe is because really our front-tier application is just making HTTP requests. We know that those sockets are going to time out. We know that those resources are going to clear themselves up. So it's fairly safe, and we've seen some positive results from doing this. So that saves us from our own code. Obviously, our node modules are mostly in the kind of standard async node pattern with callbacks, which means we can't necessarily always just do a try-catch. But thankfully, Express and Kraken give us a final middleware error handler. So if all else fails and someone's passing along a next error, we can just catch it in this final middleware, and again, we have a context of the request, and we can send the user to the right place and help them recover their transaction. The final layer of protection, obviously there are some scenarios you just cannot recover from. Process on unhandled exception, we don't have a request scope, we don't know where the error is coming from really. It could be in some code which is going to leak resources. In that case, we have to crash and restart the server. But thankfully, with the top 2 layers of protection, that's going to be very, very rare for us. So kind of finally, in checkout, we're all about conversion. We monitor the numbers, to the decimal places every single day. We're constantly making sure they're on par. We're measured by our conversion. Everyone watches it. So when we were rebuilding, we really wanted to make sure we had enough information to be able to get on par in terms of conversion. So we log everything. And moving to the front end, that makes things a little bit more difficult. On our Kraken app, we can do a log. We know it's going to get to the right place. But when we move all of our business logic to the front end and all of our flows, we have a problem because now everything's happening on the client side, and we don't really know what's going on so much. So we tackled this in a few ways. First of all, we came up with a front-end log buffer that we can log to, and we can send off our logs on each flow transition. We really didn't want to be making requests for every single error or every single thing we wanted to log. Obviously, that would really hurt our client-side performance. So we buffer those, and we flush them when we can, or when the user unloads the page, or when there's an unhandled error, we'll do an immediate buffer. Angular makes this very, very straightforward for exceptions. Any front-end developer will tell you about window.on error. We know that it does not give us enough. Quite often in legacy browsers, we will not even get a stack trace or a proper file reference. So Angular will actually catch all of our errors for us in any kind of Angular wrapped code in our controllers or our directives, which means that we can get some very detailed information about what's going wrong on the front end and log that properly. And that's enabled us to match our previous apps conversion in a matter of weeks, which has been really good. And obviously, all of this is fire and forget. We don't want to impact our users at all, so we fire off those requests, and we do all that in the background.
Yeah, it would be, just to add on to it, earlier, the first version of the checkout app, all the entire flow was actually server-side rendered, so it made it, since it was server-side rendered, the instrumentation was a little easier from the actual Kraken app side itself, the node side itself. Now that the app became more front-end heavy, the way fire and forget actually happens is the Kraken app actually, there's a logging API that's exposed, so the front end just hits the logging API, just flushes out all its logs and expects it to log to the right logging mechanisms. So basically, internally, the app would set up the right sources to which the logs go into. That's specific to PayPal infrastructure. So far, we've been talking about specific technical blocks or problems that we could attack, and we could jot down and boil it down to a bunch of requirements and actually figure out what would be the best solutions for the existing architecture. But this wasn't done like that easily. with respect to, that was a back and forth between the Kraken, like the team that I represent, as well as the team that, the checkout team that Daniel comes from. We kind of brought in more of the perspective of what it is to do more like the Node way, leveraging the tools that NPM and Node gives for free, and trying to write more very Node-specific code. And Daniel brought in more of the product-specific requirements and why certain things that we prescribe will not work for a specific product requirement. For example, the sub-apps.
Originally, we wanted this idea of NPM-style plugins, and we thought, great, let's write our own plugin loader. Let's kind of do all of this ourselves. And then we kind of got chatting with the infrastructure team and discovered that really Kraken provides a brilliant way to do this with its configuration-based middleware. So we adopted that fairly early on.
Yeah, that worked really well. And then we also had things about like trying to unit test, trying to make it truly NPM modular, such that it's self-contained. It defines the interfaces fine. It's just unit by itself that defines functionality clearly. So we kind of pushed to write unit tests for every version of the module that they were bringing up with.
So yeah, we think unit tests are really important for all of our plugins, but actually, in Checkout, one thing that we found even more valuable are our integration tests. We have a lot of different components that all interact with each other in weird and strange ways, and our integration tests actually save us a whole lot when it comes to those. So really, that's one of our really big priorities, in getting everything end-to-end tested in our app.
Yeah, and this whole process, one of the biggest wins was more like the lessons, how we kind of made the typical requirements, typical patterns that we suggest for coding Node apps versus what products generally bring in as requirements, and how to make them match and have a two-way for that. That's all we had today. Thank you very much. Please reach us out and for questions.